Howdy students, I'm back here with another example for you guys. Today we're asked to find the volume of a solid whose base is the triangular region with vertices 0, 0, 2, 0, and 1, 0, where the perpendicular cross sections perpendicular to the x-axis are semicircles. So if we look at our diagram here, hopefully it shows a little bit of depth. We see that we have a bunch of semicircles with decreasing diameter all the way until this point to C. And then we see that our region is bounded here by this linear line here from C to A. So we're going to take advantage of the fact, backtracking really quick, what we're looking for here is the radius, right? We're looking for our R, which will allow us to integrate to find the volume of this region. So what I'm going to do is I'm going to use our point slope formula here, and I'm going to let C be our point 2, so then it'll be these 2 points or variables, and then I'm going to let this and this be A. So then I have 0 minus 1 over 2 minus 0 equals negative 1/2. Okay, and then so point slope form, we get y1 equals negative 1/2, x minus 0 equals half x y minus 1 Alright, and then I'm going to move the 1 over, giving me negative 1/2. Rather, we'll do this 1 minus x over 2. Okay, so now that we have our R, we can go ahead and fill in our area formula, which would be 1 over 2 pi 1 minus x over 2. And if we want volume, we're going to integrate this. On our bounds from 0 to 2. 0 to 2 dx. Okay? So I'm going to pull out pi over 2. All right. Oh, squared, sorry. Okay, so if we notice, we have a little bit of a substitutions situation going on here. I'm going to let this inside term be u. So we see du, u equals 1 minus x over 2 du negative 1 over 2 dx. So dx equals negative 2 du. Implies pi over 2, 0 to 2, u squared times negative 2 du. Rewriting this a little bit cleaner. Squared. Okay, I can pull this in front of my integral here, giving me negative pi u squared. All right. So if we remember, these bounds were for when our integral was respect to x, but now we're integrating with respect to u. So I'm going to substitute x, both 0 and 2, into here. So this will be 2, this will be 0, 1 minus 2 over 2 is 1, equals 0. 1 minus 0 over 2 is 1. Okay? So rewriting that with our new bounds gives us (1 to 0) u squared du. Now if we notice, we have a larger bound here on the bottom and a smaller bound here on the top. So I'm going to use the fundamental theorem of calculus. Yes, fundamental theorem of calculus to flip this. So flipping this integral changes the sign, so now I get pi 0 to 1 u squared du. Now we can go ahead and evaluate this integral, giving us, pi times u to the third over 3 on the bounds 0 to 1 equals 1 over 3 minus 0. Giving us pi over 3. Another shorter example, but I hope this one made some sense. Thank you guys.